afternoon. Today on the five three-phase semi and full converter. So, see the main requirement objective of this converter. Okay. So, three-phase semi-converter perform flicker and observe the output voltage and requirements. Phase electricity, power scope, power loss. Even we require additional microscope part of this circuit, but this may be a different part. So objectives are to understand the concept of line and phase voltage phase, then understand the working of three-phase full and semi-converter, then uh, learn the role of power electronics in the speed control of induction motor, understand and design three-phase full wave converter with a CR, and even one more important part, that is to study or to learn the handling of power scope, right? So this is the circuit diagram for three-phase semi as well as full converter. Actually, this circuit is a fully controlled converter, but we are having maybe a key in which we can perform both practical and same. So if you see this particular key, then you can see here there are total six SCR, 1, 2, 3, 4, 5, and 6 SCR, right? So this is the first, second, third, fourth, fifth. Even in the same diagram, there is a diode D3, D4, D5, and D6, right? So you can perform CV as well as full converter on same key, simply connecting wire between the two SCRs and these two SCRs and these two SCRs, external connecting wires you can use. Then this becomes a fully controlled converter. And if we connect the connection between one SCR and one diode, so this connection, then another SCR with diode, last SCR with diode. So this circuit becomes a semi converter. Okay. So if you see this particular diagram, this diagram is divided into two parts. First part is a picture. This part is called a microprocessor based figuring circuit. Just a diagram. Then second part is a converter. Okay. If you see here, it's a 8255 and 8085. It is actually a microprocessor. 8255 is a digital interface, then pulse transformer, and so on for isolation. So G1, K1, G2, K2, G4, K4, G5, K5, G6. Total six pulses, gate pulses are generated. That is internally connected to the gate of every. Okay. This is the main switch for on off purpose. Now you can see here there are some additional switches. I just zoom out so that you can see this is the gate supply of the switches. These are again the gate supply. This first switch is for turn on the gate supply from G1, G2, G3. This switch for G1, G4, G5, and so until and unless you turn on the gate supply, these converters will fail. Then additionally, this is a triggering pulse adjustment. You can see here, you can adjust the triggering pulses here. So here initially it's at 20 degrees. So by pressing these buttons, upward and lower button, you can adjust any value of a trigger horizontal. Okay. And this is the microprocessor connection, that is external key to be there. It generates the triggering pulses and that are connected. So this is the actual trimmer key available in our laboratory. So we are going to perform practical on this key. This is the microprocessor based triggering circuit. So one keyboard is given here so that you can execute, you can apply the triggering pulses. This is the cable which is connected to the key. This is the complete setup of this three-phase semi as well as converter, microprocessor based triggering circuit. This is a converter, power scope, and this is a load, and we are using multimeter for DC. Now, the working of this particular diagram, that is already we have seen many times in the theory, but again I'll just explain you in a short way. So SCR1, SCR3, 6, these are the positive SCRs, a positive group of SCR. SCR4, SCR6, and SCR2 is called as the negative group of SCR. Okay. So one SCR from upper group, one SCR from lower group, if conducts, then current flow to the load. We are using here a load resistive. Now there are three phases: VR, VY, VB. In a class, in a theory, we just call it as phase A, phase B, and phase C. So VR, VY, VB, also called as VA, VB, and VC. Okay. This is actually V for blue, Y yellow, and R for red. Okay. So initially, if R is more positive and B is more, sorry, Y is more negative as per the convention given in the diagram, if R is more positive with respect to Y, SCR1 is in forward bias condition and SCR6 is also in a forward bias condition. So current flows from VR, then S, then load resistor R, then back to the 6, and then go to the VR. So that time you will get a 1 pulse. Similarly, second time, when phase B is more negative, phase R is more positive current, that time S1 and S2 both are in forward bias condition, current flow to S1, then R, then S2 back to the phase. So at a time, two SCRs are on S1, S6, S1, S2. Right? So you can see here the pair S1, S6 conducts for 60 degree, S1, S2 conducts for 60, and total conduction period of S1 is 20, right? Then S2, S3 conducts, right? So automatically the conduction period of S2 will be again 120. Then S3, S4 conduct, then S4, S5 conduct, then S5, S6 conduct, then S6, S1 conduct, then S1, S2. The cycle. Okay. So this is the working for fully controlled converter. This connection diagram that is already shown here. Then it's the table actually which SCR conducts during, that is S1, S6 first cycle, then S1, S2 for 60, S2, S3 for 60. So this is basically conduction angles are given, that is 210 to 270 S3 and S4 conduct, 127 to 330 S4, S5 conduct, or from 330 to 360 S5 and S6 conduct. Again S1, S2 conduct. Okay. The procedure is very similar to the experiment number 4, that is make the connections as per the circuit diagram, then connect the load, then connect the CRO and multimeter. Here the potentiometer is not used, we are using push to on, push to off switches to change the firing angle. Then switch on the AC source. The gate pulses are internally connected. Then observe the output waveform on the CRO. Then adjust the value of firing angle, different value, and note down the load. Okay. Repeat the steps for semi-converter. Then observation table for semi-converter and full converter, both is same. You have to just adjust the firing angle. Initially, if I adjust firing angle equal to 0, right? Initially, if firing angle is equal to 0, that time you will get a max output voltage. That is maybe 230, 280, 270, but maximum. As you increase the firing angle, the output the voltage also decreases. Okay. This is actually increasing, right? Increasing firing angle. So that time output voltage decreases 270, then 250, 230, 200, 190, and so on. Okay. So you have to observe the different output voltages on different value of alpha. At the same time, you have to observe the output waveforms. Okay. Now, fully controlled, the same maybe given. These are the waveforms for fully controlled converter. Already we have seen this is the input waveform, and this is output waveform for alpha equal to 0. This is alpha equal to 60, and so on. And these are the waveforms for semi-converter. The same kind of waveforms you can observe on the CRO. Right? Now we will go for the demo on the demo. So we will see the demo now.
Good afternoon, dear student. Today we will see the experiment number 5, that is 3-phase controlled bridge converter This kit consists of both the part, that is semi-converter, as well as fully controlled converter. This circuit is shown here, which is a triggering circuit. Every time I told you that the triggering circuit is required, but it is not shown normally in a circuit diagram. But here you can see the triggering circuit is also given. Actually, this circuit, whatever shown here, is this circuit, right? Basically, it's a triggering circuit. Microprocessor based triggering circuit is used to trigger the 6 SCRs. Okay, so a 3-phase power supply is given to the kit, and this particular kit, if you see, it consists of, see here, you can see the SCR1, then SCR2, SCR3, SCR4, SCR5, SCR6, even diode D4, D5 and D6. So on the same kit you can perform full converter as well as a semi-converter, 3-phase semi-converter and 3-phase fully controlled converter. You can change here the firing angle from this particular point. So it is maybe a 80, 90, then 100, then 110 and so on. Okay. And we are using here a resistive load. We are connecting a lamp as a resistive load. At the same time, we are connecting a power scope to see the output waveform, and we are connecting a multimeter. The multimeter is on DC mode. Okay. The triggering circuit whose output is given to this kit, so internally, which is connected to the G1, G2, G3, G4, G5 and G6. So we will first connect the semi-converter. So in this kit, we are connecting one SCR with one diode. Okay. Similarly, another SCR with another diode. Okay. And last, the SCR3 with respect to diode D6. Okay. So this is a connection. Load is connected. Right. These toggle switches are given here to turn on the gate supply. Right. Now in semi-converter, G5, G4, G5, G6 is not required. So you can turn off that gate pulses. Only G1, G2, G3. Remaining we are using diodes. And here the main supply for the gate is on. Now I'll just go for the supply. 3-phase supply turns on. So it is a 3-phase supply on. Now we will go for the triggering pulses. So triggering pulses will go for this particular keyboard is given here. So first you reset, then go, then the starting address is 4000 and then execute. You can see here the lamp is glow, right? These are the output waveforms, right? And the voltage is a 94 volt voltage, right? This time the firing angle is 110. Now I'll just minimize the firing angle, that is 10 degree. And then we will go for the V1 only. Okay. Now see, the intensity of a lamp increases. At the same time, you can check the voltage. It may be a 276 volt, and see the output waveforms, which are directly a pulses. That is a 6 pulses. So this is the firing angle 10. If I increase the firing angle 30, right? It's a 30 firing angle. You can check firing angle is 30. Now we just go for the kit and then press V1. Now check. If firing angle is increases, then voltage decreases. The intensity of lamp also decreases, and even you can check the output waveforms. Similarly, if I increase the firing angle, that is 60, and again we will go for the V1. Okay. Now check the voltage. Voltage is 206 volt, and the intensity of lamp increases because the power delivered to the load decreases. And here see the output waveforms. Okay. So this is about the semi-converter. Now we will go for the full converter, fully controlled converter. So I'll just remove the connection from diode and make the connection with the SCRs. Okay. So these are the SCR1, SCR2, SCR3 and so on. Okay. Now I'm turning on the supply. Just a minute. Okay, so similarly, we are connecting here total 6 SCRs. So the same working will be repeated for the fully controlled converter. Same kind of output you will get, and as you increase the firing angle, the output voltage also decreases. So this is about the experiment number 5. Thank you very much.